Hello and welcome to another Walking Talking Mock. This is C3, so old Spec year 13 maths, if that makes sense. This is the May 2005 paper, the first paper that's available on MEI's website. So we're going to do this one, and the plan is to obviously do all of them on this channel, but yeah, I don't know if we'll manage to do that, but we're going to try. So let's see. As always, okay, not always, but as often is the case, the first question is a modulus solving question for 3 marks. So solve the equation mod 3x plus 2 equals 1. Okay, so that means that 3x plus 2 either equals 1 or it equals minus 1. So I'm going to have 2 solutions. I'm going to have x equals minus 1/3, or I'm going to have minus 1. So yeah, I got 2 solutions there. I'm going to get a basic mark for this answer here, and I'm going to get a method mark for making it equal to minus 1 and an accuracy mark for getting the other solution. Okay, so that's my 3 marks. And that was question 1. Okay, we're on fire. Question 2. Given that, I should show you, given that arcsine x equals pi over 6, find x and find arc cos x in terms of pi. 3 marks. Okay, so arc sine x equals 1/6 of pi. Find x. Okay, well, that means what is sine of pi over 6, basically. That's what that means. And so x equals sine of pi over 6. Pi over 6, that's 30 degrees. Sine of 30 degrees, that's a half. Okay, obviously I could use my calculator for that, but you know. Find arc cos of x in terms of, okay, so what is the inverse cos of a half? Well, that's pi over 3, isn't it? Yeah. I was going to say, you know, there's infinitely many answers to that, but that's not true. If I was just saying like inverse cos, like shift cos, cos minus 1 of half, then yeah, I would be saying that there's infinitely many values. But because we're specifically saying arc cos, which is a function, there can only be one answer, because functions only have one answer, yeah? Okay, so that's done. Let's see what marks we're going to get. We're going to get a basic mark for getting a half. We're going to get a method mark for doing this. And we're going to get an accuracy mark for getting pi over 3. And bear in mind, you will not get the accuracy mark if you put 60 degrees, and you will not get the accuracy mark if you put whatever pi over 3 is, like 1 point something. You're not going to get the mark for that. Okay, number 3. The functions f of x and g of x are defined as follows for the positive x domain. F of x is log x, g of x is x cubed. Express composite function f of g of x in terms of log x. Okay, f of x is log x, g of x is x cubed. So f of g of x, we're putting g inside f, so that's log of x cubed. And we know that there is a simplification we can do there, which is to put the power at the front. So that is 3 log of x. And that's what it means when it says express it in terms of log x. You would not be allowed to write log x cubed as your final answer because it's not in terms of log x. Yeah. So let's see, we're going to get m1 for that, and we're going to get a1 for that. There's another part to the question that I almost didn't see. State the transformation which maps the curve f of x onto f of g of x. So how do we get from log x to 3 log x? Okay, it's multiplied by 3, so that is a stretch parallel to the y-axis, so vertical stretch, scale factor 3. Yeah, and that's also worth a basic mark. Okay, question 4. The temperature, T degrees Celsius, of a liquid at time t minutes is given by the equation T equals 30 plus 20 e to the minus 0.05 t, for t greater than or equal to 0. Let me jot that equation down. Okay, write down the initial temperature of the liquid and find the initial rate of change of temperature. Find the time at which the temperature is 40 degrees C. So we've got 3 questions there. Initial temperature. It says write down, I don't need working out. Okay, initial means when the time is 0. So if the time here was 0, that would make 0. E to the 0 makes 1. 20 times 1 is 20, so that would be 50. Okay. And then initial rate of change. Okay, rate of change. So dt by dt. Rate of change, means with respect to time in this case. Okay, if differentiate that, it's going to go away. Differentiate this. Okay, when you differentiate e, you times by the thingy, by the power. So that is, what's 20 times 0.05? I feel like it is probably 0.1, but I don't trust myself. Yeah, okay, it's 1. So yeah, good job I didn't trust myself. So it's 1 e to the minus 0.05 t. I almost forgot the minus as well. Oops. Okay, and then, so I want the initial rate of change, so I want t to equal 0. So, minus e to the minus 0.05 times 0. Oh, that's just minus 1, isn't it? I should probably put some units. Degrees Celsius per, what's t, second? No, minutes. Degrees Celsius per minute. Find the time at which the temperature is 40. Okay, so I want 30 plus 20 e to the minus 0.05 t to equal 40. So let's just solve this equation. Equals a half. Let me just scooch over here. I'm going to rearrange that to make it log to the base e of a half equals minus 0.05 t. So t is log of a half divided by that. Obviously, in this case, because it's like a question, it's like a scientific-y kind of question, they obviously want a decimal as their answer. So I'm just going to go log of a half divided by 0.05 minus, divided by minus 0.05. Yeah, I'm wondering why I had a negative time. Does it say significant figures? Or what should I give it to? That's got 3 significant figures, kind of. Or it's got 1, you can't really tell. Let's go for 3 significant figures. 13.9 minutes. Yeah. I could say 13 minutes and like 50-ish seconds. Like I could convert it. That would be That'd be okay as well. Let's see what marks we're going to get. So we get B1 for the initial temperature. We get M1 for the correct derivative. We get A1 for -1. You also get A1 if you've written 1 instead of -1. You still get the accuracy mark. That's really weird. What else? M1 for taking logs. So this step here gets M1. Oh no, wait, I missed one. You also get M1 for just equating it to 40. And then accuracy mark for the answer. It says 13.86 or 13.9 or 13 minutes 52 seconds or better. Condone seconds. So if you accidentally wrote 13.9 seconds, you'd be okay. Interesting. See, sometimes examiners are nice. That paper's too black. Get rid of it. Question 5. Using the substitution u equals 2x plus 1, show that this integral equals this thing. 6 marks. Okay. U equals 2x plus 1. And the integral 0 to 1 x over 2x plus 1 dx. Okay. So if I'm going to use u equals that, then I need to find du by dx, which is 2, which means that half of du equals dx. Okay. So I should also change the limits. Or see, there's 2 ways you can do it. You can change the limits at the start, or you can ignore the limits completely and at the end just change everything back to x and then keep the limits as they are. But I was always taught to change the limits. So when x equals 1, u would equal 3. When x equals 0, u would equal 1. So this is the integral from 1 to 3 of, okay, the bottom is going to be u, but the top, what's the top going to be? U minus 1 divided by 2. Isn't it? Okay, u minus 1 divided by 2 over u du, but I need to put a half somewhere as well. Stick it on the front. Okay, I think I want to get rid of that dodgy fraction that I've got going on there. So let's divide this by a half. So stick it on the outside. Like that. That looks a lot nicer now. Okay, I think I also, I could separate that into 2 fractions. Like I could say this is u over u minus 1 over u du, which makes it easier because then it's just 1 minus u minus 1, like that. Or if you don't think you would have thought of that, there is also the option of doing u minus 1 times u to the power of minus 1, like that, and then expanding that. So u times u to the minus 1 is 1, and then 1 times u to the minus 1 is minus 1, like that. Yeah, so you do end up with the same answer, it just depends how you would think of it. Okay, so now we're going to integrate it. I'm going to leave the quarter at the front. Integrate 1, you get u integrate u to the minus 1. Well, that would be log u. And then put 1 to 3. So that's a quarter. You know, Mr. Edwards would actually hate me right now. Okay, that's better. Please don't tell him I did that. Okay, so this is 3 minus log 3 minus 1 minus log 1 . 3 take away 1 is 2, minus log 3 plus log 1. I can't really do anything with that at the moment. Okay. Oh, log 1 is actually just 0, isn't it? Well, even if it wasn't, I can use the log rule that says you can turn an addition of logs into a log of a product, which would be log of 3 times 1, which is log of 3. So, yeah. That is just 2 minus log 3. And I guess I would just leave it as that. Oh, wait. Yeah. I'm definitely going to leave it as that, because that's what the answer was supposed to be. Excellent. So, in terms of marks, let's see the mark scheme. I'm going to get method for doing the du by dx bit here. I'm going to get accuracy 1 for, is that for the limits? It's not very clear. No, accuracy 1 is for this. And B1 is for the limits. Okay. M1, oh, by the way, if you don't convert the limits, but then you convert it back to x and use the original limits in the end, you'll pick up that B1 just because, like, you know, you dealt with the limits, basically. M1 for dividing through by u. What do you mean by that? I think it means getting it into this kind of format. It must mean that. Accuracy 1 for a quarter of u minus log u. Okay, accuracy 1 for that. And E1 for having evidence of substitution. So, like, this bit is E1. I can't remember what E stands for, but it's the mark you get when the answer is already given to you in the question, and it's like a show that question, and they call it E, but I don't know. I'm not actually sure why it's called E. Yeah. Okay, that's done. Question 6. Let's see. A curve has equation that find dy by dx, hence find the exact coordinates of the stationary point of the curve. Okay, so y equals x over 2 plus 3 log x. Find dy by dx. Okay, this is a quotient, so I think I shall use the quotient rule. U equals x and v equals 2 plus 3 log x. Du by dx is 1, and dv by dx is, how do you differentiate log again? Well, if you integrate 1 over x, you get log. So if you differentiate log, you get 1 over x. Am I correct in that? Yeah, I'm pretty sure. So that's 3 over x. Okay, so dy by dx is, using the quotient rule, v du by dx minus u dv by dx. Oh, that's good. That just becomes 3. I should probably write it like that, even though I know that becomes 3. I should probably write it like that, just in case they're, you know, if for some reason, like, I just had one of those, like, blonde moments and it wasn't, then there wouldn't be evidence that I've used the quotient rule correctly. So I would lose my method mark as well as my accuracy mark. Whereas if I write that down and then later do something stupid with it, I'm only going to lose the accuracy mark. So just to be on the safe side. And then I've got v squared. Okay, let's simplify this. 2 plus 3 log x minus 3. It's not really any reason to expand that, so I won't, but I will do 2 take away 3, which is minus 1. Yep, I'll leave it as that. And then I want stationary points, so for stationary points I need that to equal 0. For a fraction to equal 0, the top of it is going to have to be 0, the bottom is kind of irrelevant. So 3 log x minus 1 equals 0. So 3 log x equals 1, log x equals a third. So x equals e to the power of a third. And I will just leave it like that because it says exact coordinates. So that's my x value. I'm going to need my y value since it said coordinates. So y equals e to the third over 2 plus 3 log of e to the third, which is e to the third over 2 plus, let's see, log of e to the third is just a third, and 3 times a third is just 1. So it's that. So that's a third of e to the third. So the coordinates, e to the third, e to the third. Let's see what marks we get. M1 for using the quotient rule, or you can use the product rule by just like fiddling it a little bit. So yeah, I used the quotient rule. B1 for this derivative here. They're not going to give me a mark for this because it's too easy, but you get a basic mark for this. You actually just get a basic mark for knowing that the derivative of log x is 1 over x. So you might get away with like doing something weird with the 2 and you still get the mark. Accuracy 1 for that. And then M1 for making the numerator of this 0. And accuracy 1 for the x coordinate. Correct answer only. So no follow through marks there. M1 for then doing the substitution for y. And accuracy mark for the y coordinate. Again, correct answer only. So if you found x wrong, you're not going to get the mark for y. And it says it must be exact. So if you've got a decimal, you're not getting the accuracy mark. So yeah. And there we go. So 7 marks. It's not bad. It's not bad. Okay. Is that all of section A? Nope. We got one more question. I think, should I do this as a 2-part video? It'd be easier to upload in 2 lots. And that way, if you only want to watch part B, because, you know, you're clever, then I guess that makes it easier for you as well. Okay, so question 7, last question of section A. Figure 7 shows the curve defined implicitly by this equation, together with the line x equals 2. Nice. Find the coordinates of the points of intersection of the line and the curve, and then find dy by dx and the gradient. Okay, so y squared plus y equals x cubed plus 2x. That's the equation of the curve, and I want that to meet x equals 2. So the intersection point will just be where x equals 2 in this, so I'm going to sub x equals 2. So y squared plus y equals 8 plus 4, which is 12. And I've got a happy little quadratic to solve. But it looks like it's going to factorise, so that's good. Minus 4, plus 4 minus 3. So y is minus 4 or 3. Does that make sense? Yeah, it's just a little bit off centre, so it makes sense that that would be a little bit less than that one. Cool. And the x coordinate is obviously 2, right? So 2 minus 4 and 2, 3. Okay. Now I'll find dy by dx. Okay. Differentiating with respect to x. Alright, if I differentiate y squared, I get, okay, well if I differentiate it with respect to y, I get 2y dy dx. And then that's going to be 1 dy dx. I think I just said something wrong then. Did I say if I differentiate that with respect to what I meant was like if I differentiate it in terms of y, but I didn't really mean that. You know what I mean. You know what I mean. X cubed just becomes 3x squared, and 2x just becomes 2. Okay, I've got 2 dy by dx is there, so let's factorise it out to gather them together like that, and then I'll make dy by dx the subject. +1. Cool. Okay. Hence, find the gradient of the curve at each of these 2 points. So at 2 minus 4, I'm just going to sub that in. It's 3 times 2 squared plus 2 over 2 times minus 4 plus 1. I bet the gradient's the same at both those points. What do you think? It looks like it should be the same. We'll see. 12 plus 2 is 14. Minus 8 plus 1 is minus 7. So that's minus 2. And then at 2, 3, oh wait, I said the same, but what I meant was the opposite. Like, the same, but negative. Yeah, I think that's what I mean. 3 times 2 squared plus 2 over 2 times 3 plus 1. So that's obviously 14 over 7, which equals 2. Yeah, that was right. I could just kind of tell that if I'm looking at the picture. Some symmetry there. Okay, let's look at the mark scheme. So M1 for substituting x equals 2. A1 for y equals 3. And A1 for y equals minus 4. M1 for implicit differentiation, and the left-hand side must be correct. And A1 for correct answer only here. Then we get M1 for substituting 2 and 3. It must require both x and one of their y to be substituted. Okay, M1 for a substitution. And then we get A1 for that answer, A1 for that answer. That question has 5 accuracy marks. It's an 8-mark question with 5 accuracy marks. And the accuracy marks are correct answer only. So that is quite harsh. Like, that's not a good question. A good question is one that has lots of method marks, lots of basic marks, and if it does have accuracy marks there, not correct answer only, but yeah. This, by the way, this is where you lose your marks, yeah? You don't lose your marks because you don't know how to do maths. You lose them because you make a mistake, and if the question has 5 accuracy marks in it, then you're probably going to lose all 5 accuracy marks from one mistake. Now, the question doesn't tell you how many accuracy marks are in it, which, you know, is annoying. It'd be nice to know, I think. But it's just something to watch out for, especially when you're doing like your practice papers in your free time. When you're marking your papers, make sure you're applying the mark scheme really correctly, and don't say to yourself like, oh yeah, well I would have got those marks, I just made a mistake there, but yeah, I would have got them, I'm just going to give myself the marks. Don't do that, because you know in the real exam that's going to happen too, and you know, you will lose the marks for real. Okay, I'm going to do section B in a separate video, so I'll see you then. Bye!